Just going to show you some conic sections as eccentricity changes. So you can see that I have the equation here. So this actually starts out as the unit circle. And what I'm going to do is I'm going to change E. So what you have to do is kind of watch the equation and watch the graph at the same time, or look back and forth. So you can see as soon as I changed the eccentricity, it changed into an ellipse because these numbers are no longer the same down here. So A and B switched, and also it's bigger vertically because A is under here. That's a larger square than that, but not much larger, but it is larger. So I'm going to keep varying that. And you can see now you can actually notice on the graph that it's becoming more elliptical. And we're also approaching 1, so we know what happens at 1. And if you watch the equation, as soon as the eccentricity changes to 1, it changes. Now there's only one squared term, so we're dealing with a parabola. But that's the only way I'm going to get a parabola. So as soon as I change this again, make it a little bigger, now you can see we picked up a minus sign here, and it equals 1, so it's still in standard form. But where's the other part? So I have to scroll up a little here. And you can see it became suddenly a hyperbola, and as I keep changing it, it becomes kind of wider and wider. And you can also see that for whatever reason, it's changing from standard form to occasionally, as I vary it, it actually changes to general form. That must be a rounding issue or something. But anyway, it gets more and more extreme. And remember, there's always the issue when you're dealing with technology of, undefined, what? I guess that's the issue right there. It's having trouble coming up with the equations at this point because, although it's definitely still a hyperbola, and let me show that to you. So this is a limitation of the technology, but I don't know how much we really expect out of it. You can see I have to zoom way in for it to look like a hyperbola. So these are all the sorts of things you have to be aware of when you're using technology and kind of playing around with these things. Let me do this, and there it goes back to giving us equations. But you can see here even it's rounding so much that it thinks it's dividing by 0, which is probably where the undefined is coming from. But that's how it works. So the relationship between eccentricity and the equation. You might be wondering how I did this. So let me show you a couple of things that are built in. What I did was I'm using polar coordinates to graph the conic section. And conic sections in polar coordinates really you just need the eccentricity. And this would be the polar equation if it was possible to graph polar in GeoGebra, which it's not. So to use polar, I also had to use parametric equations. And these are all things that you're going to learn about as the year goes on. So eventually you'll be able to do it. And then to get the equation, I actually, GeoGebra has a built-in function called conic through 5 points. So after I defined the equation, got it to give me the equation, I put 5 points on it and asked GeoGebra to just find the equation. So a lot of stuff going on in the background on this. But the main point is when it's 0, you get a circle. When it is 1, you get a parabola. In between 0 and 1, you get an ellipse, and greater than 1, you get a hyperbola. I was going to try to get the view back to something reasonable, but I don't know if I'm going to be able to do that. Probably not, because I'm not a genius when it comes to changing these sorts of things. Now I can't even find the origin. Oh, man. Anyway, good luck with that. I hope this is a little bit helpful.